This video is going to go over the Pythagorean theorem. This is going to be one of the first couple things you cover in your geometry class, so just make sure you're paying attention and trying some of these problems. So, in a right triangle, the way you can tell it is a right triangle is when it has a right angle, and normally this will be indicated by a little square in the corner. So if we look at the side opposite that corner, so if you shine a flashlight on this corner, it's going to point to the longest side, which we call the hypotenuse. So most of you guys probably have heard these terms before, which is fantastic. Okay, so the next two sides, we don't have specific names for each of them. We call both of them the legs of the triangle. So we have the hypotenuse and the two legs. Now, the Pythagorean theorem describes the relationship the Pythagorean theorem describes the relationship of the lengths of the sides of a right triangle. So the sum of the, the sum of the square of the lengths of the legs equals the square of the length of the hypotenuse. So this is kind of a way to explain the Pythagorean theorem in words. Most people find it easier just to work with the actual equation. So the equation is a squared plus b squared equals c squared. It doesn't matter which side is a and which side is b. The one that is important is c. C has to be the hypotenuse. And then a and b are both the legs of the triangle. So that's the important thing. C, or the hypotenuse, has to be at the end of the equal sign. That's the one thing you really got to remember. So let's look at some examples. We are finding the missing side depending on what information is given. So if I look at my first one, I have two legs, A and B, and then my hypotenuse is what I'm trying to find. So I'm going to set up my equation, but I'm going to plug in my numbers. So A was 5, B is 9, and then the hypotenuse is x. So now I'm going to follow my order of operations. So order of operations tells me to square or take care of the exponents first. So I have 25 plus 81 equals x squared. Oops, sorry about that. Okay, add our two numbers together. Looks like we get... And to finish solving this, we want to get the x by itself. So to undo a square, we take the square root of both sides. Okay, so let me put this up here. So normally when we get a square root like this, our next step is to simplify it. We never want to leave this radical not simplified. Kind of like a fraction, you always want to simplify. So to simplify it, let me change colors here. Let's do green. So I would break it down into two factors. So I find two numbers that multiply to equal 106. Let's see, it's even, so I can divide it by 2. So 2 times 53 gives you 106. So 53, if I try to break it down, there's no numbers that can divide 53. That's one of our prime numbers. So I have 2 and 53. There are no pairs of numbers, so that means no numbers can be taken out. So in this case, it cannot be simplified, and your final answer is just the square root of 106 centimeters. So it looks really weird, but that is your final correct answer. So with number 2, if you would prefer, you can draw the triangle and label the sides, or you can plug them into your formula. So just really quick, if I do a rough sketch of my triangle, B is what we are trying to find. A is 3, C is 5, or my hypotenuse is 5. So plug them into my formula, my Pythagorean theorem. And just make sure the 5 is on the outside of the equal sign. So once I have my formula or my equation, all I have to do is simplify and move stuff around. So I have 9 plus b squared equals 25. Subtract that 9 to the other side. And then we square root both sides. And now for this one, I have the square root of 16. I know that one is a perfect square. And if you didn't remember that's a perfect square, you can always break it down using the factor tree like we did before. Okay, so those are 2 types of problems. The one other problem you can see are word problems. So for number 3, we have 2 identical trees are 5 feet apart. Sitting atop one tree, a flying squirrel glides from his position to the base of the second tree. If the trees are 42 feet tall, what is the distance traveled by the squirrel? Okay, so I would highly, highly recommend drawing pictures for these. So let's see what my art looks like. Okay, so I have a tree here. My pen wants to work. Doesn't want to work today. Okay, there we go. So I have a tree here. I have a tree here, and they tell me they are 5 feet apart. Come on. 5 feet apart. And then the trees are 42 feet tall. And then, so the flying squirrel is up here. And he is going to glide down to the base of the other tree. So this is what we are trying to find. Sorry guys, I'm not even going to try to draw the squirrel with how my iPad's working today. Okay, so the side we are trying to find is our hypotenuse. So all I have to do is plug my numbers into my Pythagorean theorem. So I got 42 squared plus 5 squared equals x squared. So 42 times 42, grab a calculator for that one. 5 squared is 25. Now I add these up. And then for this one, I would recommend using your square root button on your calculator. Because a lot of times when you have a number this big, it is a perfect square. Okay, so we square root both sides. If I plug it in to my calculator, I get that the square root of that is not a perfect square. So I would try breaking it down, and you just have to test different numbers. So try dividing 1,789 divided by 3. Then try 4, try 5. Once you try a bunch of things, you'll actually figure out this one is prime. So the distance traveled by the squirrel is the square root of 1,789 feet. So for all of these, you're just plugging your numbers into the Pythagorean theorem. Just make sure you're following order of operations and labeling your hypotenuse correctly.